In this video, we're going to talk about the difference between area under a curve versus area enclosed by a curve in the x-axis. And these two phrases sound almost the same, but they actually mean something very different when we're thinking about integrals and area. So the area under the curve, that means the net area. And this will be exactly the integral. But the area enclosed by a curve in the x-axis is asking for a total area, or a gross area. So while area under a curve, or net area, is asking us to consider whether area is positive or negative, area enclosed by a curve in the x-axis is asking us only to think about area as positive. So this is going to be the absolute value of the integral. So if we think about an integral, an area related to an integral, it can be positive. It's going to be positive when the area is above the x-axis. And area related to integral can also be negative. So it's going to be negative when the area that we're looking at is below the x-axis. Whereas the gross area, the total area, when we're just thinking about the area enclosed by the curve, it's always positive. The total sum of all areas. Where we don't even think about whether that area is meant to be positive or negative related to the x-axis. So in this graph example, we can calculate the integral, the area, just based on the graph, so without even having an equation, because we're going to think about it as area of triangles. So for the area under the curve, this is going to be exactly the integral. We're going to look at the area from this x value to this x value for our function. So we're going to look at the integral from 1, 2, 3, 4, 5 on the positive side and negative 4. Let's call this function f of x. And we're going to find this just by summing the different areas and then thinking about whether those areas are positive or negative. So if we look at this first area right here, it's a triangle, so we can find it using half the base times the height. So half of the base will be this length, which is 4, and the height will be this length, which is also 4. So half of 4 times 4, half of 16, and this area here is 8. So this piece of area contributes negative 8 to the integral. It's negative because it's below the x-axis. Now this next portion of the graph, right here, again, that's a triangle, so half the base, which is 3, times the height, which is 2. Half of 3 times 2, half of 6, which is 3. So this piece of area contributes positive 3 units to the total area. And then finally, this piece here, again, is a triangle, so half the base, which is 2, times the height, which is also 2, gives half of 4, which is 2. So our area for this final little triangle piece is -2 because the area is below the x-axis. So then when we look at our integral here, that total integral is the sum of all of these areas for the function on the interval. So we would have -8 and +3 and -2. And that sum will give us our total area. So -8 plus 3 minus 2 is equal to -7. So our area under this curve is -7. Well, how does that change when we're thinking about the absolute value of the integral, or the area enclosed by a curve in the x-axis? So we have the same f of x here. We're just going to treat all of these area pieces as positive. So that means that we are looking at the absolute value of each of these areas. So this area, we've already found that the area of this triangle is 8. Now it's +8 because we're just thinking about the total area enclosed by the curve in the x-axis. This area here is +3, and this area is +2. So the total area is going to be 8 plus 3 plus 2, so 13. So normally we're going to be considering the area under the curve, or the net area, which in this case is given by this value. But do be familiar with this idea of enclosed area being a gross or a total area, when instead of thinking about area being positive or negative, it is always positive, in this case with area enclosed by the curve in the x-axis.